Alright, here we go. Last section, Mr. Sullivan showed you his Halloween costume. This is actually my son's first Halloween costume. Can you guess what he is? That's right, he's a pumpkin. If it's Halloween right now, by the way, you are a boss, because that means you start in August, and it's Halloween, and you're on Chapter 9. Incredible. If not, hopefully you're right on pace with us. We're doing circles, so maybe you're wondering, like, hey, I see a little baby inside a pumpkin. That's pretty cool, you know, he's like 2 weeks old. What is the area of that pumpkin? I don't know, you could be wondering that, and you're probably thinking, what's the volume? Well, volume you're going to have to wait for Mr. Sullivan in Chapter 10, but area we can do right now. So let's move on. Let's take a look at area of circles. Excellent. So I'm going to give you a lot of vocab this time, so if I go too quickly, pause me, rewind me, whatever you got to do. Let's make sure we know what a circle is. So here's the definition of a circle. I know you've been dealing with them for a long time, but there's the formal definition. Set of points equal distance from the center. So in my little picture over here, D is the center of the circle, and then there's a bunch of stuff, and hopefully this is just a quick review. I'm not going to give formal definitions, but in this case, what DC is what it is the radius. So there's just an example of the radius. What is the radius? It starts at the center and goes to a point on the perimeter of the circle here. So we know radius. What's the other important thing we need to know? In this case, what is AB? If I look at AB, AB is a diameter, and that goes through the center all the way across. So we're looking at something like that. So just a couple things to make sure we have it. Do we know how to find the area of a circle? It is pi r squared. So we can go to it's a cool proof. If we have some time, we'll go and prove where that comes from. Circumference. I do want you to know what is the circumference is actually just a fancy way to say perimeter. So when we're talking perimeter, and we've looked at it a little bit in some of these sections, what's the perimeter of the circle? Well, it's saying what's the circumference? It is 2 pi r. So pi r. Pi is this magic number, you know, it's the circumference divided by the diameter. It's a pretty cool number. We're going to use 3.14. It's approximately 3.14. It was just Pi Day for us, so that's pretty awesome. You can use the calculator button if you want. It's a little bit more precise, but when we round it, 3.14 is cool. So hopefully we're good with this. Let's make sure we can manipulate this. And again, I'm sure you've done this in the past, so I'm going to go quickly here. Two ways we're going to do this. We're going to find the approximate, which means give me the decimal. So if area is pi r squared, you know, the diameter is 16, so I know this is 8 and 8, so just cut it in half. You know, radius is half the diameter. So if I'm finding this and I want to find the decimal, you know, I'm going to say it's pi times 8 squared. So to find the area, 8 times 8 is 64. We're saying that's 64 pi. Go over to your calculator, and you can type in 64. You can use the pi button. It's right above the caret here. If you want to use the pi button, that's cool. Usually, though, I mean, I'm going to just say 64 times 3.14. I like to just type it out. That's what I usually use. Either way is cool, but I'm gonna usually say use this and round it to the nearest tenth or the nearest hundredth. So depending on directions is how far we're gonna round it. So either one of these are good answers. The calculator button's a little bit more precise if you want to use that one. How about this though? What if I say find the diameter? So if I say find the diameter given the area, so now I know the area. Can you find the diameter? Well, first I got to relate it back to radius. Once I get the radius, then I'm good to go here. So yeah, how do I solve this? Well, I'm looking for r. How do you solve for r? Well, you got to get r by itself. So the first thing you're going to do is divide by pi. So I'm going to have to go straight to the calculator on this one because I don't know what that is. 28 divided by 3.14 is what? Looks like 8.9. So we're going to cut off at one decimal. This is 8.9, where I'm going to round it, is r squared. So what do I got to do now to solve? I don't want r squared. I want r, so what do you have to do? Square root both sides. So I'm looking at the square root. Square root button is above the x squared in blue. So square root of 8.9 is what? 2.98. So if I round 2.98, if I round that the 8 up to the 9, it actually makes it 3, doesn't it? So just to be more precise, so we know, if you give me more decimals, that's okay. I'll be very specific in the instructions. So this time I went to the 100th, 2 decimal places, and this is the radius. So I know it could be plus or minus, but you can't have a negative radius. So when you introduce square root, it's plus or minus, but it can't be a minus because you can't have a minus a negative radius. So that's the radius. What's the diameter? Well, diameter is 2 times the radius, you know, so it's double it. So we have to double 2.98, so you can go back to your answer right here, times that bad boy by 2, and we're looking at 5.96. We can go ahead and round that up to 5.97. So the diameter in this case would be 5.97. So that's approximate. You know, I'm using decimals, I'm rounding, I could get a little bit off. So sometimes I don't want the approximate, I want the exact value. So when I do the exact value, I'm going to leave it in terms of pi. So I want to see pi in your answer because it never ends. It's 3.14159 blah 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 forever and ever. They've calculated to like millions and millions of decimal places and they're still calculating right now. So we're just going to use this pi symbol. It never repeats. It's an irrational number. So when you want to find circumference, get some notation. This is circle P. One way to refer to this is circle, put the center in it, and circle P. That just means circle P, so if you ever run into that, don't freak out. That's the same thing as circle P. Alright, so can we go ahead and find the circumference of circle P? Let's do that here. So we're going to use 2 pi r. There's the circumference right there. So we're going to say circumference equals 2 pi and the radius there is 10. So we're going to say 2 pi r. Awesome. This is the exact value, so we're going to leave it in terms of pi. This is great. These are actually easier. 2 times 10 is what? 20? 20 pi. That is my actual answer. So you can leave it like that. It's going to be 20 pi centimeters. So don't put in your calculator. Leave it exact value just like that. The circumference is 2 pi r, so it's not too bad. It's 48 equals 2 pi r. Again, I want to get radius by itself, so can you solve this for r? Sure, no problem. You know, pi is just a number, so I'm going to divide by 2 pi on this side. To get r by itself, I'm dividing by 2 pi. So what I can do to this side, whatever you do to the left side, you got to do to the right. So the 2's cancel, the pi's cancel, I'm left with r, and I'm left with 48 over 2 pi. Can I reduce that? Sure, a little bit. Let's just, we don't have to do a ton to this, but to leave it exactly in terms of pi, the 2 goes into 48 how many times? Should go in there 24 times. So this is 24 over pi. That is the exact value of my radius. And if I want to put it in terms of meters, it's 24 over pi meters. Excellent. Very good. So if you want to put in your calculator and find the approximate, you could, but we're going exact. Alright, let's get some more vocab here. So, when I'm talking the central angle of a circle, what am I talking about? Well, the central angle of a circle is an angle whose vertex is the center of the circle. So, we've got a bunch of central angles in here. You know, here's one right here, here's another one right here, and even this big one over here is a central angle. So, we've got a bunch of them. Remember, if I want to name that central angle, I would say something like CDB, because D is the center. So what we're going to start looking at is arcs. So what in the world is an arc? Well, an arc is a part of a circle. It's part of the actual perimeter or the circumference of that circle. So I'm going to look at these different arcs. So if I look at the arc for angle 1, you know, angle 1's right here. This is the central angle. Its matching arc is this over here. That's what matches up with it. Excellent. So one other piece of vocab we need is a semicircle. Ooh, look at that one coming in from the side. Woohoo! I love it. It didn't show up though. Give it to me. Give it to me. Oh, there's nothing there. My flare did not work. Let's see. Alright, so a semicircle is just half of a circle circumference. So it's halfway around the world. Semi means half, so it's halfway around the circle. Excellent. So can we put this into what we're going to call minor and major arcs? So what is a minor arc? So it all relates back to a semicircle. If a semicircle is halfway around, then a minor arc is smaller than that. So how do I name these things? So I was talking about angle 1 up here. And let's talk about this. It's the distance from C to B. So it's if I walk just that part of the perimeter, how far am I walking? So how do we name that? I'm referring to CB. I just take the 2 letters and put a little arc on top. That's how you do it. So a minor arc is smaller than a semicircle. Remember, a semicircle is halfway around it. So what is a major arc? You guessed it. It's bigger than a semicircle. So that's less than that. Let's go bigger. So maybe I went from C, walked to B, but I went right past it, and I got to come all the way over here to A. See, I've gone more than half the circle. So this, how do I name that? Well, you're going to need 3 points. I can't call it CA. If you call it CA, what are you actually talking about? You're actually talking about this arc from here to here. So to show that it's a major arc, I got to go from C through B to A. So if you're talking a major arc, you need 3 points. If you're talking 2 points, we're going to go to the shortest one. We're going to go minor arc on it. So 3 points for a major, 2 points for a minor. So excellent. And again, if you want the semicircle, it'd be from like A to B. Excellent. Very nice. So that's all our different things. So why is this important? You're probably wondering. Well, we're going to do a lot with this. First, let's make sure we're okay naming it. If I want to name the arc for angle 1, so angle 1 is the central angle. Who's its arc? Well, it corresponds straight to this one. It's a nice minor arc, so all I got to do is say LK, put a little arc on it. How about the major arc, though? The major arc for angle 1 is what? Well, it's the opposite of that. It's what if I went the other way? So if I'm naming that, I'm going all the way around with here. So I'm going to start with L. You can pick any point it hits, either I or J. I don't care. I'm going to say I, and I'm going to end with K. That's like Leica. There we go. So there's the major arc for angle 1. It's the big one. What is the one that makes opposite that little one? Very cool. Can you go backwards? What if I tell you, yeah, what's the central angle formed by GH? So here's the arc by GH. Who does it make? It makes angle 1. So no problem. It kind of goes both ways here. How about IGJ? So if I'm looking at IGJ, let me erase my old one here, and we'll do this one in red. So if I go from I to G to J, what angle is it naming? Well, it's a major arc for which one? Remember, you're naming angle 3. It's this angle formed here. So it's the major arc for angle 3. The minor arc would be JI. Excellent. Very good. So that's naming it. Now we're going to start finding them. So a little bit of just, can we find it? Well, yeah, I want to find this question mark. Well, it turns out what we call here is, if this is a 130 degree central angle, this is a 130 degree measure of arc length. So if that's 125, the measure of this arc length is also 125. So how do I find the rest? Well, what do circles add up to? That's right, circles got to add up to 360. So if I want to find this missing piece, I got to subtract 130 from 360. That's 230. And then I got to subtract that 125, and what am I left with? I'm left with 105 degrees. So this missing piece is 105 degrees. If that central angle is, what is this? 105. So this chunk, we say the measure of that arc length is 105 degrees. Fantastic. They can get kind of crazy, though. You know, I got a bunch of central angles, a bunch of different arcs. I'm looking at just this chunk, which means I just want this angle. Well, I got to use all this other information here. So, what do I got? Well, if this is 42, look, I got vertical angles here. Old school, man. That's chapter 1, vertical angle. So that's 42. And now how do I find that missing angle? I'm interested in this red one. Well, look at this. This is a semicircle. Straight line. What do they add up to? 180. So, this is one way to do it. A couple ways to do it. So, 42 plus that angle I don't know plus 80 adds up to 180. So that's one way to do it. So 42, the question mark, plus 122 is 180. So subtract them. What does your question mark equal? Should be what, 58 degrees? So if that's 58, then my one out here is 58. Fantastic. And it should work on this semicircle. Here's another semicircle. This one plus this one plus this one is also 180. Excellent, and that's the same, would have been the same equation. Very good, so that's finding the measure. So let's define that a little bit. So we just talked about it. The measure of an arc length is what? It just corresponds to the central angle. It's the measure of that. If I'm finding the measure of arc length, I'm going to put a little m in front of it. So I may ask you something in the future like, oh, I don't know, what is the measure of arc length CB? And I'm looking for something like, I don't know, maybe that's 80 degrees. So this would be 80 degree measure of that arc length. So that's one thing we can do with this. And that's important for a couple reasons later on. But what I want to move on to is saying, okay, what is the actual distance? What is the measure of how far did you walk? So what if I want to know how far did you walk from C to B? Love these problems. This one has a lot of applications for us. So let's do it. Let's take a look at this. First of all, if I'm talking perimeter, I'm going to do some arc lengths with this. So what is the ultimate all the way around the circle? Well, it's the circumference. So this is our opening problem. It's 2 pi r. Plug your 10 in there. I know my circumference is 20 pi. 2 times 10 is 20. 20 pi. So all the way around is 20 pi. So what if I ask you, what if I made this a semicircle? So cut that in half. And I said, what is the measure of this? Well, if the whole thing's 20 pi, what is that? Well, it's 10 pi, isn't it? No problem. They're each 10 pi because you cut your circle in half. So if I cut that circle in half, I just take half of 20. That would give me my semicircle. What if I want to break this down even more, though? What if I want to break it into quarters? So these are all, what, 90 degree angles? 90, 90, 90, 90. So what is each one of these arc lengths now? So let's change it. They're not 10. What do they break down into? Every single arc length up here, you know, is what? We've got, let's put a little green on this, just from here to here. Well, if the whole thing was 10, this turns into 5 pi. Well, how do you do this? This is 1/4 of the circle. So one way to do it is say, what's 1/4 of the perimeter? It's 1/4 of 20 pi. So now, really, I could break it down more, couldn't I? What if I don't want to know a quarter, but I want to know 30 degrees of it? Well, the key is how much of the circle is 30 degrees. So to find this, we're talking about an angle theta. So to find arc length, let's do one. Maybe it's easier to do one just to see what it's all about. And I hope I left you room here. Let's do this 30 degrees. So I want to know 30 degrees. So the key is how much of a circle is 30 degrees? Well, it's 30 degrees out of what? 360 degrees. That's your fraction. We were doing that with 1/4. 1/4 we knew was what? 90 out of 360. And 1/2 was what? 180, semicircle out of 360. That's 1/2, 1/4. So this is, I want to know 30. So really, let me clear out some of this junk I have in here. I'm just looking at a 30 degree, and it doesn't matter how we draw it. Let's do it this way so we have a little room. If this is 30, I want to know what is the distance from there to there. So it's 30 degrees out of 360. And then what am I doing? I'm just timesing it by the circumference, which is 2 pi r. In this case, our radius was 10. And so now it's just a matter of simplifying. 30 over 360 is what? How many times does 30 go into 360? Well, it should go in there 12 times. So really, this fraction is 1/12 times 20 pi. That's intense. And we'll simplify it down below. We'll do a couple more. But I want to know this generic formula. What is the generic formula? Well, if I want to find an arc length, I'm talking about any angle theta to find its matching arc length over here. So the formula says you take whatever the angle is. I'm going to call it theta. That's theta over 360. I'm going to times it by the circumference. So here is the actual formula. So this right here is theta to measure the angle. All right, let's try some of these. So we have approximate. We're going to do approximate, and we're also going to do exact values. So I just want this highlighted part, that solid black region there. So I just want that little chunk of it. So what do? Well, I'm going to, the angle's theta. The central angle is theta, so it's 45 over 360. Times it by 2, times it by pi, times it by r. In this case, r is 16. And it says approximate, so I can go to my calculator. I love when it's approximate. What do you got to do here? You just type it in. It's 45 divided by 360. You can hit enter if you want. You don't even really need to, though. And you're going to times it by 2, times it by pi. You can use the pi's button, or 3.14. Times it by its radius, 16. That is the approximate 12.56. So really, this is 12.56 miles. So if you were going to walk from here to here, that would be 12.56 miles. Excellent. So what if I don't draw a picture? You could draw your own picture and say, okay, I know 126 degrees up is 90, so it's a little bit more. There's my picture, radius 16. But it's the same thing. You take 126 out of 360, that's how much this angle theta is, times it by 2 pi r, the circumference. So we're just breaking down our circumference, or our perimeter. And again, let's just multiply it out. It's the same thing. I'm going to take 126 divide it by 360, times it by 2, times it by pi, times it by r. And what do we get here? 35.16. I'm going to round that up to 35.17. And it was in miles as well. So that's what part of the circle we found. So we're actually physically finding from here to here. Fantastic. Last two, and we got it. What if they say exact values? So we can still do this in exact values. I want to find this major arc length here, not because this one's in bold here. So the major arc length. So I'm looking at 240 out of 360, times it by 2, times it by pi, times it by the radius is 12. So 240, this reduces. Can you reduce it? Well, if you have to go back old school math frac, I don't mind. You can just type in 240, divided by 360, and you can math frac it. If you do that, if you math frac it, it's going to tell you the answer. It is 2/3. And if not, do it longhand. As long as you come up with the right answer, I'm cool with that. So this is really 2/3 times, what is 2 times 12 is times 24 pi. And again, if you got to use your calculator, but I can multiply that out. What is 2/3 of 24? It should be 16 pi. So that is the exact value. 16 pi centimeters long is how far that solid one is there. But if you got to go calculator, put in parentheses, multiply it out, math frac it, whatever you're going to do, you're good to go. All right, one more. So if I'm going to do this, if you want to draw your picture so you can see what's going on, I'm talking about a 60-degree angle right here with a diameter of 24. Almost got me. So what's the radius? The radius is 12. So make sure you got a radius of 12. I'm looking at a 60-degree angle here. Let's find it. So I'm trying to find how far I'd walk along that line right there. So I'm looking at 60 out of 360 times it by 2 pi r. And 60, that's 1/6. 60 out of 360 is 1/6. Again, we're timesing by 24 pi. And this works out well. What's 1/6 of 24? It is 4. So this is 4 pi centimeters. That's how far you'd walk. Fantastic. All right, so we've done the best human beatbox. We've done the best air guitar. Now we're going to end with the best ping pong point ever. Good luck on that mastery check. Peace out.
係要掌握個時間等等都要好好，所以佢頭先係失咗。咁但係相反喎，現時歐洲嘅運動員咧，比賽都用呢板啦，放下突然間削一板咧，令到你難以亦都應付㗎。嗱呢板靚啊，再一板發力，好衝㗎。陳生話夠埋一個車身，再一個關斗，再夠埋㗎，再放高，盡量表演。嗱許真才呢板咧，呢板。 縮矮仔啦，俾佢啊！嗱，如果陳新華呢個波自己唔擋啦，俾許真才擋翻個仲精彩嘅，咁變咗佢就趕唔翻個檔咯喎。